All right, so what we're going to do is we're going to get a little more realistic, and we are going to talk about probability of compound events. Okay, so for example, just to kind of review what we talked about, if probability, right, was a heading, remember we talked about theoretical probability and experimental probability. Theoretical, we talked under this heading here, we first learned about simple events. Okay? Well, compound events actually are also under the theoretical heading. So we're going back to theoretical just because it has more to do with actual math. In sort of a weird way, you can actually kind of connect the two of these as well because they are interrelated. You're going to see some simple events in the compound events part. Okay, so that's what we're talking about. We're going to compound events. All right, so two vocab words. The first one is compound events. Everyone? Compound events. Here's what your book says compound events are. They are two or more simple events. Two or more simple events. So, for example, you have a spinner and you have a number cube. What's the probability of spinning a 6 on the spinner than rolling a 2 on the number cube? That's an example of a compound. So it's just two or more simple events. It's like you're doing two games within one game. That's an easy example of compound events. Now, during this time, I'm going to show you a couple of different strategies on how to solve compound events. Okay? And sometimes either one of them would work. There's other times where maybe only one strategy will work. And we'll talk about that in a bit. But one of the strategies we're going to use is something called a tree diagram. Everyone? Tree diagram. Okay, and you guys have probably seen a tree diagram before. But maybe not when it comes to probability. But I'm going to share this with you. So, first of all, this is a diagram used to show the total number of possible outcomes. This is a diagram used to show the total number of possible outcomes. And you can either write that whole thing. I'm actually okay with you just putting possible outcomes with compound events. Okay? It's a strategy for compound events we can use. All right, now, really quickly, here's what I want to do. Let's say and I just want you guys to watch this part. This is an I do, not we do. All right, let's say I put up here 4 cards. And I want to know, using the same 4 cards, what is the problem? I can only win. I'm going to have 2 drawings of these cards. That's the rule. I get to draw two cards. Okay, I'm going to pick one, put it back, and pick it and try it all over again. The only way I win is by choosing a 1 on the first drawing, and then on the second drawing, choosing a 4. Okay, that's the only way I win. That's a favorable outcome, is I have to do both of those. All right, that's, of course, an example of compound event. Now, here's what I want to introduce to you guys. You don't have to write this down. I want to introduce to you guys a tree diagram for me to find the probability of this happening. Okay, so here's what a tree diagram is. I'm actually going to flip this over for a second. Probability of a 1, then a 4. Okay, so if I was to do a tree diagram, the cards that I just saw, this is probably good information, are numbered 1, 2, 3, and 4. It's that simple. Basic cards 1, 2, 3, and 4. Okay? Here's how you use a tree diagram. The very first thing you're going to do is you're going to list on the first event, okay, you're going to list all the possible outcomes on the first event. So in this case, the sample space is what I'm talking about. I can pick a 1, I can pick a 2, I can pick a 3, and I can pick a 4. I'm spacing them out because in just a second I'm making a tree diagram. I'm going to make branches coming off of this thing. So here's what I do next. I turn around and say, there's our first event. Now I'm going to make a row of my second event. So I can choose a 1. After the 1, after I put the card back, what can I choose next? I can choose a 1, I can choose a 2, I can choose a 3, and I can choose a 4. If I chose a 2, 1, 2, 3, 4. A 3, 1, 2, 3, 4. And after I choose a 4, a 1, 2, 3, 4. To be able to read this, here's what this means. I can choose a 1, and then I can turn around and choose a 1 again. I could choose a 1 and then a 2. I could choose a 1 and a 3, or I could choose a 1 and then a 4. That's all if I chose a 1 first. Or I could have chosen a 2 the first pick, and then chose a 1 the second, a 2 and a 2. Okay, I'm not going to say them all, but hopefully you guys get the idea. This is a tree diagram. That's what each branch represents. So if I was to write this outcome, here's what I would do. I would say, all I have to do is count the end of my branches. Those are my sample spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 16 possible outcomes on this game. 16 different ways I can pick these cards. I'm looking favorable outcome, choosing a 1 and then a 4. A 1 and then a 4. Is there any other place here where I can choose a 1 and then a 4? Nope. There's my only favorable outcome out of all these branches. It is only in one spot. I have a 1 in 16 chance of winning this game. Okay? This is compound events by using a tree diagram. All right, so when it says tree diagram, that's what it's talking about. Any questions? And we're going to do a problem like this in just a bit. Any questions on tree diagrams? Okay, now let's go back to the game. I'm going to show you the second way that we can win this game. Or I'm sorry, to find out the probability of this game. Not a second way we can win. The only way we can win is the same here. This compound event is made up of 2 simple events. Let's look at the first simple event. Just by itself, what is my chance? Remember, these cards have a 1, a 2, a 3, and a 4 on them. What is my probability of choosing a 1, guys? Okay, let's use a fraction. A ratio, 1 in 4 chance. Let me see. Hey, look at that. Okay. Let me do this again. Huh? You know where it is now? No. Okay, here we go. Okay. Now, let's get back to the lesson, the game. Okay, here we go. We have a 1 in 4 chance. I just chose it. I put it back, and it has to be random, right? So I'm not looking. I shuffle them. Here they are. Okay, listen carefully. Now, we want to know. Now let's find the probability by itself of the second event happening. What's the probability of this? 4 is on one of the cards out of 4 total cards. the probability of this happening, does anyone remember it?
116.
Anyone think they may come up with an algorithm by looking at those numbers?
4 times 4 equals 16.
Yeah.
4 times 4 equals 16.
Okay, what about fractions? What? Yes, good job in my advanced students. All right. 1/4 times 1/4 equals 1/16. Ladies and gentlemen, the faster way of doing this is find the probability of the first event, find the probability of the second simple event, and multiply the probabilities together. And you say, well, Mr. Williams, why'd you even deal with the tree diagram? Well, because this here is not always so simple. Okay, and we'll see a problem where even though we know this skill, it doesn't quite work out the way it's worded and the way it comes across. Okay, so we're going to look at some of these problems. All right, so with that said, any questions on the game or about any of that? Okay. All right, here we go. Okay, in our book, make sure we're on page 484. 484. All right, so number 4 is 484. All right, says use any method to find the total number of outcomes for each situation. So listen, in this lesson, here's what I want to do. I want to do it both ways with you guys, just for you to have notes in your book, all right, or on your homework, all right? So let's go ahead and we'll call this the TD for you football fans, all right? The tree diagram method, okay? Here we go. For number 1, it says find the number of tennis shoes available if they come in gray or white and are available in size 6, 7, or 8. Okay? Now, it is not asking about the probability. It's just asking about the total number of outcomes. So here's what we're going to do with the tree diagram. Step 1 is we can say the first event or the first what I've called element. And in this case, when we're talking about the shoes, it's about the color. So my colors are gray and white. Now listen, I don't expect you to write those out, but we write down G and W for gray and white. We'll simplify it for ourselves. Now, step 2 on using a tree diagram is then we're going to come up with the second event, or in this case, the second element of this, and that is the shoe size, 6, 7, or 8. So how many different ones are there? 3. So that means that off of each of these are 3 branches. 6, 7, 8. Or you can have the white in 6 or a 7 or an 8. Now, when using a tree diagram and you're only finding about the possible outcomes, that bottom number on probability, all you're doing is you're counting the bottom of your branches. So how many possible outcomes? 6 outcomes, right? You have a gray as a 6, a gray 7, a gray 8, or a white 6, a white 7, a white 8. 6 outcomes. And that, of course, is where you come out with your answer. Okay? Okay, a pretty simple tree diagram. Now comes, let's talk about, we'll call it the FCP, which is really the fundamental counting principle. We didn't go into detail about that definition, but basically it's the algorithm. All right, so here's what we do. Step 1. Oops, I put step 2. Step 1. If we're only finding about the number of possible outcomes, you don't say which ones they are of the first element. You just say how many are there. There's 2 of them, 2 colors. Step 2. Again, you don't say what the sample space is on the next element. You say how many are there in the next element? Well, there's a 6, 7, and 8. There's 3 of them. Right? And then step 3 is we multiply. And we get 6 outcomes. Okay? So we're only talking about we're not talking about probability on this one. We're kind of we're talking about probability, but we're talking about that bottom number, meaning the total possible outcomes. Okay? Questions? Okay, because of the time, I'm going to move on to the next type of problem. All right? So, page 484, let's take a look at problem number 4. It says Amber has a denim and a black purse. Ebony has a black, a red, a denim, and a brown purse. Each girl picks a purse at random to bring to the mall. What's the probability the girls will bring the same color purse? Okay? Now listen, here's what they're asking. What's the probability of that story? The same color purse. Now here's the issue. What's the probability of the first event? What's the probability of the second event? Okay, I wanted to do this with you guys because some of us see the fundamental accounting principle and go, oh, I'm going to use that every time. But unfortunately, there's not always a chance to use that. Okay, there will be some in your homework, and you can use either way you want depending on the problem. In this particular case, we're going to have to use the tree diagram. Okay? So, listen carefully. Okay? Amber has a denim and a black purse. That's our first element is Amber's purses in her style or her color. So a denim color and a black purse. Okay? And I'm not going to write the steps because this is just your basic tree diagram steps that we just talked about. The next element, of course, is Ebony's purses. She has a black, a red, a denim, and a brown. Okay? So let me ask you, how many are there? 4. So that tells us how many branches. So here we go. It is a black, so I'll put B. A red, I'll put an R. A denim, I'll put a D, and a brown, I'll put, well, the first one was what? Black. For brown, I'll put BR. You don't want it 2 B's. That might be confusing. I want to make sure they're different. All right? And then with the black, for Amber, Ebony can also bring a black, a red, a denim, or a brown. So I guess if we're going to write major steps, I'd say step 1, build your tree diagram. Step 2, count the number of possible outcomes. How many possible outcomes? 8. Step 3, favorable outcomes. Remember, same color. A denim, and of course Ebony would have to bring a denim. If Amber brings a black, that means that Ebony has to bring a black. Are there any others that match? Nope. So, how many are there? 2 favorable outcomes. Now, of course, we can call this step star as a reminder, but of course, there's a 1 in 4 chance. It doesn't say to write a percent or anything else. It just asks about the probability, and that's our probability. All right, so probability of compound events.